Episode 1. Title of the radio enabled learning course is Energy Physics. In this paper, we will learn about energy sources, energy from oceans, wind energy, biomass energy, and solar energy. First, we will discuss about Introduction to energy sources. Energy is the primary and most universal measure of all kinds of work by human beings and nature. Everything what happens in the world is expression of flow of energy in one of its forms. Most people use the word energy for input to their bodies or their machines and think about crude fuel and electric power. The energy sources available can be divided into three types. One is primary energy sources, second one is secondary fuels, third one is supplementary sources. First, we will discuss about primary energy sources. Primary energy sources can be defined as sources which provide a net supply of energy. Coal, oil, uranium, etc. are examples of this type. The energy required to obtain these fuels is much less than what they can produce by nuclear reaction. Their energy yield ratio is very high. The yield ratio is defined as the energy fed back by the material to the energy received from the environment. The primary fuels only can accelerate growth, but their supply is limited. It becomes very essential to use these fuels mostly. Primary fuel contributes considerably to the energy supply. Then we move on to secondary fuels. Secondary fuels produce no net energy, though it may be necessary for the economy. This may be or may not be yield net energy. Intensive agriculture is an example where in terms of energy the yield is less than the input. Finally, we discuss about supplementary sources. Supplementary sources are defined as those whose net energy yield is zero and those requiring highest investment in terms of energy. Insulation, that means thermal, is an example for this energy source. Coal, natural gas, oil and nuclear energy using reactor are net energy yielders and are primary sources of energy. Secondary sources are like solar energy, wind energy, water energy, etc. Solar energy can be used through plants, solar cells and solar heaters. Solar tower is another emerging technology. Solar drying and solar heating are economical application when passive methods are used. Because of dilute nature of solar energy, it is difficult to classify the source as a primary one. Better sources are wind, tide, wave and hydroelectric application. Geothermal and ocean thermal are the other sources which may well prove worthwhile. It may be necessary in future to develop the secondary sources like solar, wind, etc. From this introduction, we will move on to Unit 1 Energy Sources. In this unit, we will discuss about Introduction to energy sources and their availability. Then what is renewable energy and non-renewable energy and other energy resources. Chemical energy, nuclear energy, energy storage and distribution systems. Okay, energy sources and their availability. Today, every country draws its energy needs from a variety of sources. We can broadly categorize these sources as commercial and non-commercial. The commercial sources include the fossil fuel, that means coal, oil, natural gas, hydroelectric power and nuclear power, while the non-commercial sources include wood, animal waste and agriculture wastes. In an industrialized country like USA, most of the energy requirements are met from commercial sources, while in an industrially less developed country like India, the use of commercial and non-commercial sources are about equal. First one, commercial or conventional energy sources. Major sources of energy include fossil fuel, water power or energy stored in water, and energy of nuclear fission. First we will discuss about fossil fuels. Solid fuels, mainly coal including anthracite and brown coal, lignites and teaks. Liquid and gaseous fuels including petroleum and its derivatives and natural gases. Minor sources of energy include sun, wind, tides in the sea, geothermal, ocean thermal electric conversion, fuel cells, thermoelectric generators, etc. Wood was dominant source of energy in the pre-industrialization era. It gave way to coal and coal. Use of coal reached a peak in the early part of 20th century. Oil get introduced at that time and has taken alternate share from wood and coal. Wood is no more regarded as conventional sources. Hydroelectricity has already grown to a stable level in most of the developed countries. A brief account of the various levels in most developed countries, a brief account of the various important sources of energy and their future possibilities is discussed in this chapter detail. The percentage use of various sources for the total energy consumption in the world is: coal is used 32.5%, oil is used 38.3%, gas is 19%, uranium is 0.13%, hydro source is 2%, wood is 6.6%, waste is almost 1%. Coal, oil, gas, uranium and hydro are commonly known as commercial or conventional energy sources. Looking at the percentage distribution, one finds that world's energy supply comes mainly from fossil fuels. The heavy dependence on fossil fuels stands out clearly. One of the most significant aspects of the current energy consumption pattern in many developing countries is that non-commercial sources such as firewood, animal waste and agriculture wastage represent a significant 8% of total energy used in the world. 4 times the energy produced by the hydro and 16 times the energy produced by nuclear sources. In some developing countries, non-commercial energy sources are a significant fraction of the total resources. This depends of the developing countries is likely to continue unless replaced by other alternative sources of energy. First, we will discuss about coal. Since the Advantages of industrialization. Coal has been the most common source of energy in the last 3 decades. The world switched over from coal to oil as a major source of energy because it is simpler and cleaner to obtain useful energy from oil. Modern steam boilers burn coal in any of its form as a primary fuel. Coal developed vegetables matter which in the past geological ages. Trees and plants falling into water decayed and produced peat bogs. Soil pressure, heat, movement of the earth distilled of some of the box gases matter to form brown coal or lignite. With the commissioning of an additional 500 megawatt unit at the Carbothermal Power Station on March 23, 1989, the power station has become the largest power station of India. The plant is located on the west bank at the Hadio River near Koba in Bilaspur district of Madhya Pradesh. The project is the second in the series of super thermal power station being set up by the National Thermal Power Corporation, that means NTPC. The gigantic complex has been set up into 2 stages. In the first stage, 3 units of 200 megawatt were set up. In the second stage, 3 units of 500 megawatt have been set up. With the commissioning of the last 500 megawatt unit, the plant has achieved its ultimate capacity 2100 megawatt. The 500 megawatt generator have been provided by BEL. The whole project has costed rupees 1875 crores. The World Bank has assisted to the tune of US $600 million. Madhya Pradesh, Maharashtra, Gujarat and Goa are benefited from the project. Accordingly to estimates, coal is most important sources. It is enough to last for 200 years. However, it is low in value and its shipping is expensive. Then we move on to oil. Almost 40% of energy needs of the world are fed by oil. The rising prices of oil has a considerably strain to economy of the world more. So in the case of the developing countries that do not possess oil reserves enough for their own consumption. With today's consumption and a resource amount of 250,000 million tons of oil, it would sufficiently for the about 100 years unless more oil is discovered. The question is whether an alternative to oil would then be available. The world must start thinking of change from the economic dominant by oil. Refining petroleum or crude oil process our fuel oils. India is not particularly rich in petroleum reserves. The potential oil are located in India are Assam, Tripura, Manipur, West Bengal, Ganga Valley, Punjab, Himachal Pradesh, Kutch, eastern and western coastal area, in Tamil Nadu, Andhra Pradesh and Kerala, Andaman and Nicobar Islands, Lakshadweep and its continental adjoining these areas. Diesel power plants in India are installed in isolated places and the total installed capacity is estimated as 0.35 million kilowatt. That means less than 2% of the total installed capacity in the country. No addition to this expected near future. Next important resources is gas. Gas is incompletely utilized at present and huge quantity are burned off in the oil production process because of the non-available of ready market. The reason may be the high transportation cost of the gas. To transport gas is costlier than transporting oil. Large reserves are estimated to be located in accessible areas. Gaseous fuel can be classified as gases of fixed composition such as acetyl, ethylene, methane, etc. Second one is composite industrial gases such as produced gas, coke oven gas, water gas, blast furnace gas, etc. Next major resources is agriculture and organic waste. At present, small quantities of agriculture and organic waste consisting of straw, saw, dust, package, garbage, animal dung, etc. Most of the remaining material was burned or left unused, causing considerable environmental problems. The waste should be utilized near the sources in order to reduce the transportation cost. Appropriate equipments for burning or extracting energy from the material should be developed to suit the local conditions and meet the requirements of rural areas. Other non-energy uses of the material should also considering the availability and the location material produced. These resources are recorded as an important energy supply for the rural areas in the near future. Next one is water power. Water power is developed by allowing water to fall under the force of gravity. It is used almost exclusively for electric power generation. In fact, the generation of water power on a large scale became possible around the beginning of the 20th century, only with the development of electric power transmission. Prior to the water power plants, hydroelectric plants were usually of small capacities, usually less than 100 kilowatt. Potential energy of water is converted into mechanical energy by using prime moves known as hydraulic turbines. Water power is quite cheap where water is available in abundance. Although capital cost of hydroelectric power plants is higher as compared to other types of power plants, but their operating costs are quite low as no fuel is required in this case. Hydroelectric power is one of the indirect way in which solar energy is being used. The main factor in its favor is that it is the only renewable non-depleting source of the present commercial sources. In addition, it does not create any pollution problem. The development rate of hydropower is still low due to the following problems. In developing a project, it will take about 6 to 10 years time for planning, investigating and construction. High capital investment is needed and some parts of the investment have to be derived from foreign sources. There are growing problems on relocation of villages involved, compensation for damage, selecting the suitable resettlement area and environment impact. Next one is nuclear power. According to modern theories of atomic structure, matter consists of mini particles known as atoms. These atoms represent enormous concentration of binding energy. Controlled fission of heavier unstable atoms such as uranium 235, thorium 232, and artificial element Pu 239 liberate large amount of heat energy. This enormous release of energy from relative small mass of nuclear fuels makes this source of energy of great importance. The energy released by the complete fission of 1 kg of uranium 235 is equal to the heat energy obtained by burning 4,500 tons of high-grade coal or 2,200 tons of oil. The heat produced by nuclear fission of the atom of fissionable material is utilized in the special heat exchangers for the production of steam, which is then used to drive turbo generators as in the conventional power plants. However, there are some limitations in the use of nuclear energy, namely high capital cost of nuclear power plants, limited availability of raw materials, difficulties associated with disposal of radioactive waste, and shortage of well-trained personnel to handle the nuclear power plants. The uranium reserves in the world at present are small. The reserves are recoverable, but they are very expensive. Further, it is estimated that the uranium reserves have only 3% of the energy contained in the oil reserve. A country like France produces about 30% of its total energy by nuclear method, whereas country like India has uranium sufficient enough only to produce 6 into 10 to the power 6 kilowatt requirements. Development of fast breeder reactor, which is not yet free from technical difficulties, will decide the future of nuclear power. Controlled fusion may also add brighter prospects to the use of nuclear energy. In India has considerable resources of nuclear fuel which would help develop of nuclear power in the country. The indicated and inferred reserves of uranium are two locations, Jagunda and Narbat Pahar and Baditin in Bihar, total about 33,000 tons. There are other important deposits in Bihar and major deposits in Madhya Pradesh and Himachal Pradesh, Uttar Pradesh, Rajasthan, and are in exploratory stage. Uranium may be in a position to sustain about 5,000 to 10,000 megawatt of nuclear power for its lifetime. In India, abundance of thorium deposits are available from monazite sand in the west coast. Therefore, India's interests lie in thorium breeder reactors. Next one is solar energy. Solar energy has the greatest potential of all the sources of renewable energy, and if only a small amount of this form of energy could be used, it will be one of the most important supplies of energy, especially when other sources in the country have developed. Energy comes to the earth from the sun. This energy keeps the temperature of the earth above in the colder space, causes current in the atmosphere and in ocean, causes the water cycle and generate photosynthesis in plants. The solar power where sun hits atmosphere is 10 to the power 17 watts, whereas the solar power on Earth's surface is 10 to the power 16 watts. The total worldwide power demand of all energy needs of civilization is 10 to the power 13 watts. Electricity can be produced from the solar energy by photovoltaic solar cell, which convert the solar energy directly to electricity. The most significant application of photovoltaic cell in India are the energy of pump set for irrigation, drinking water supply and rural electrification coverage, street light, community TV sets, medical refrigerators and other small power loads. Next we move on to wind energy. Energy of wind can be economically used for the generator of electrical energy. Wind are caused from two main factors. One is heating and cooling of atmosphere, which generate convection currents. Heating is caused by the absorption of solar energy on the Earth's surface and in the atmosphere. Second one is the rotation of Earth with respect to atmosphere and its motion around the sun. But the wind energy following problem are associated. First one is wind energy available is dilute and fluctuating in nature. Because of the dilute form, conversion machines have to necessarily large. Unlike water energy, wind energy needs storage means because of its irregularity. Wind energy systems are noisy in operation. A large unit can be heard many kilometers away. Large areas are needed to install wind farms for electrical power generation. These are the major drawbacks of wind energy resources. Next one is energy from biomass or biogas. The potential for application of biomass as an alternate sources of energy in India is very great. We have plenty of agriculture and forest resources for production of biomass. Biomass is produced in nature through photosynthesis achieved by solar energy conversion. As the word clearly signifies, biomass means organic matter. In simplest form of the reaction is the process photosynthesis in the presence of solar radiation can be represents water plus carbon dioxide in front of solar energy. CH2O plus O2 is formed. In the reaction, water and carbon dioxide are converted into organic material, that means CH2O, which is the basic molecule of forming carbohydrate stable at low temperature. It breaks at high temperature, releasing an amount of heat equal to 112,000 calories per molecule. Biomass resources fall into three categories. Biomass in its traditional solid mass, that means wood and agriculture wastage. Biomass is non-traditional form. The third category is ferment the biomass molecules to obtain a gas fuel called biogas. Next one is ocean thermal energy conversion is most important energy resources. This is also an indirect method of utilization solar energy. A large amount of solar energy is collected and stored in tropical oceans. The surface of the water acts as the collector for solar heat, while the upper layer of the sea infinite heat storage reservoir. The heat contained in the ocean could be converted into electricity by utilizing the fact that the temperature difference between the warm surface water of the ocean and the colder water in the depth in about 20 to 25 degree Kelvin. Utilization of energy with the associated temperature difference and its conversion into work form. The basis of ocean thermal energy conversion, that means OTEC system. The surface of water which is at high temperature could be used to heat some low boiling organic fluid. Thank you.